Okay, here's the 3D moment problem. I want to see if you can do r cross f, and then I want to see if you can do r cross f dot u. So here we go. It says find the moment of the force about A. And the moment is always, in 3D, just r cross f. It's actually r cross f in 2D, but we can do that by just doing force times perpendicular distance. Unless you are a savant at looking at things in 3D, you're going to have to do r cross f in vector form. Okay, we want to know the moment about A, and so what you can do, remember, you take any r from point A to the line of action of F. So you could take r from here to there, from here to there, from here to there. It doesn't matter. Remember, the force, you could take the force anywhere along the line of action. Remember that picture of Katniss shooting the arrow? And then you just take any r from A to that line. Well, the only spot where we have a coordinate of where F is on that line is right here. You don't have a choice in this problem. So your r is going to be from A to D. That's the only r from A to the line of action that we know the coordinates. The vector from A to D, and this is the total r, not the unit vector. So the r from A to D, you have to walk over 2.5 in an x. They're on the same line. If you look at the picture carefully, they're on the same y coordinates. So there's 0, y. And you have to go up 4k, going from A to D. The f is given. We just got r, so all that's left is to do r cross f. My calculator can do it, so I just put this in my calculator and I got r cross f. If you don't have a calculator that can do cross products, this is what you do. You do I, j, k. Make sure you put the r next, so 2.5, 0, 4. And then you put the f, and the f was, let me go look it up, 50 minus 20 minus 80. Oh, there it was. It's written right there. And you take the determinant of that. I'll leave it to you to go through the notes to figure out how to do that. The next part of this problem is to find the moment of the force about the axis AB. Fortunately, the first part found the moment about A, so that's already on the line. So that's one of the points on the line. And so all you have to do is take this answer. Here's the moment. Okay, r cross f. We already know that is 80I plus 400J minus 50K. That's r cross f. And all that we have to do is dot it on the unit vector of the axis we want, which is the unit vector AB. To get the unit vector, again, you just get the r from A to B. And if you look at the picture carefully, to go from A to B, you have to walk 3.5 in the x, 0.5 in the j, and they're on the same plane, so you don't have to go anywhere in the z direction to get from A to B. And there we go. We need to now turn that into a unit vector. This one is not a real nice one. The length is this weird 3.536. And you divide it by that, and I was too lazy to divide it, so I just left it in fraction form. And then you're just going to do the cross product. Here, again, was the answer from part A, r cross f. We just got this unit vector here, and just do the dot product. And remember, to do the dot product, you take 80 times 3.5 over 3.6. Then you take 400 times the y component of the u, and then you take the 50 times the z component, which is 0, and you get this. So remember, the dot product is you multiply the x's, multiply the y's, multiply the z's, and add them all up. Okay, and finally it says change that to a vector. Well, all you do is you just take the number, that's the scalar, 135.8, the answer for part B, and just multiply it by the unit vector. That changes it into a vector. Remember, it's the magnitude times the direction. And if you multiply everything out, that's what you get for the vector.